So we are going to talk about sum and differences of cubes today. I only have 6 examples for you because we don't have to get too terribly in depth. But the great thing about differences of sums or cubes is there is a set formula, very similar to what we did when we factored our differences of squares. There was a formula. Remember, sum of squares is not factorable. So what we're going to do is we're going to factor cubes today. So when you do cubes, you have to think differently. You can't look for those square numbers. You have to think of cubed numbers. So make sure you're familiar with these cubes. Now, the rule with the exponent on a cube is it has to be divisible by 3. So you can have a to the third or a to the sixth or even a to the ninth as long as it's divisible by 3. What a cube is not is a square or a to the fourth or a to the sixth. So we're looking for straight up cubes. Now, there is a set formula. So when we factor a sum of cubes, a cube plus b cube, we're going to have a binomial factor every time, a plus b, and then we are going to have the same trinomial factor, a squared minus ab plus b squared, every time. When we factor a difference of cubes, notice that my binomial factor is a minus b this time, and I have the same trinomial a squared plus ab plus b squared. Now this is a set formula, and we are going to just substitute and work out the problem from there. So I'm going to jump right on in. Keep in mind these numbers in the box. You need to be familiar with those. Okay. So similar to what we did when we factored a difference of cubes, this time I need to break up the cube. Now, 64 squared is 8, but 64 cubed is, or the cube of 64 is 4 to the third power. It's up here in my list. See how 64 is the same as 4 to the third. So my binomial factor is the x plus 4. And then I have to take care of the a squared minus ab plus b squared. Well, this is your a value, and this would be considered your b value. So I would have x squared minus 4x, multiply these two values together, multiply your a and your b, and then your b squared plus 16 on the end. That would be the final factoring of that sum of cubes. Okay, now in the second scenario, I'm going to break it up into my cubes. 27 is the same as 3 to the third, so I now have my a cubed minus my b cubed. Now the formula is a little bit different, so y minus 3, that's always going to be your binomial. But this time the trinomial is a squared plus ab plus b squared. So I would have y squared, remember this is a, this is b, y is a, 3 is b. I would have plus 3y plus 9. This sign does not change. If you are factoring a sum of cubes, a difference of cubes, the binomial factor has that plus sign. For a sum of cubes, the binomial factor always has the opposite of what the original problem was. So please pay very close attention to that. For number 3, I have 1 cubed, first number in my list, plus k cubed. So that is going to give me the binomial factor of 1 plus k. Now, since I am doing a sum of cubes, I'm going to put this trinomial. This is the trinomial that goes back in. So that would be 1 minus k plus k squared. And that would be the factors of the sum and differences of cubes. Now I told you we're only going to do 6, so I'm going to scroll down and we're going to do a few more. Okay. Now, when it comes to factoring completely, you have to be able to see the difference between a difference of squares or whether it's a cube. So these three problems mix and match those skills. So the first thing in number 7 that I see is the fact that that is an x to the 4th, which is not a cube. I cannot divide that power 4 by 3. So that would indicate to me, if I can factor it, it's going to be a difference of squares. So that would be x squared squared minus 6 squared, and that would give me x squared plus 6 and x squared minus 6. Now, before I say that this is my answer, I do have to check and make sure that that is not an additional difference of squares. X squared minus 6 is not, because there is no number you can multiply by itself to get 6. So I do not have an additional difference of squares in that particular problem. So be very, very, very careful when you do those problems. Sometimes you will, sometimes you will not. In number 8, the first thing I see is the fact that I have a greatest common factor of 2. Now, when I take out that greatest common factor, what is left just so happens to be a sum of cubes. So that is what I'm going to factor. So I have a to the 3rd plus 2 to the 3rd. So now I'm going to fill in my gaps, my binomial and my trinomial factor. So I would have a plus 2. Now remember, that 2 has been coming along the greatest common factor the whole time. I do need to use this trinomial. So a squared minus 2a plus 4. And those would be my factors. My greatest common factor I took out at the beginning, my binomial factor and my trinomial factor of the difference of squares, a to the 3rd plus 8 that I got when I took out that greatest common factor. So the last one that we're going to do is number 9. You can see that c to the 4th, that would be a difference of squares. It cannot be a cube because the exponent 4 is not divisible by 3. So I do have a common factor, which is 3. That leaves me with 9c to the 4th minus 4. Since I am going to try to factor this as a difference of squares, that would be 3c squared squared minus 2 squared. So the end result for that particular problem, number 9, greatest common factor 3, and then I get 3c plus, or 3c squared plus 2 and 3c squared minus 2 as the conjugate factors of the difference of squares, 9c to the 4th minus 4. So if you have any questions about factoring difference of squares and cubes within the same problem set, just let me know. Don't hesitate to ask.